Alright, so I thought, since we covered measurement last time, that we'd talk about calipers again today. So I had them kind of in order. So we can start with these two, right?
Tiniest we own.
Yeah, not just tiny. The way they're measured matters too, right? So remember last time we talked about the measuring we were doing was just dividing an inch into parts, right? I'm off the camera, aren't I? No, we might be on the camera still. All right. So all we do is divide an inch into parts, right? Well, that's what these do. So you have the scale up here, and it just divides the inch, and it's got metric too. Divides the inch, and this one's nice because you see it's got the fractions marked for you: quarter, half, 3/4. But they don't go very small. You can't read that very well. If you get really tiny measurements, it'd be hard to read, right? And this one does the same thing. This is kind of a cheaper one. But it does the same thing. It allows you to measure fairly accurately. If you want to measure like the size of this marker, it measures it pretty good, right? And that one does the same thing. If you want to measure the size of this marker, ta-da, we can read our measurement using the line. And that's pretty handy. But if you want to be more accurate, we need to divide it up even more, right? And this is the start of that. So this is a vernier caliper, which is kind of like this, but it divides it up even smaller. So this one measures in 1/16. So this one measures in 1/16 of an inch, right? That's a 6. But see this vernier? See these little lines right here? Those divide it further. So what happens is each of these little lines here is a 1/16, and then each of these little lines right there adds a 1/128 of an inch. And in order to figure out what the measurement is in detail, you have to measure stuff like this, and then you have to do math. So you measure how many 1/16ths there are, and then you add however many 128ths there are. You do a lot of lowest common denominator stuff, and you reduce the fraction to get your actual usable measurement, right? They make these in thousands, and I really kind of want one in thousands, but I don't have one. But this one is, I never use this one anyway. I probably never use the thousands. So then we can get a little more detailed, right? So let's see these ones. These ones here are a little more closer, right? So they're different. This one's digital, and this one is a dial, right? These still don't really measure into thousandths, though. This one kind of has a little, but not really very accurately. So this is mostly still for fractions, like lumber and measuring small stuff. I use this a lot for woodworking and stuff like that. So it has your fractions lines up here, and it does the same thing. It measures, and then your fractions. And this one, you'll like this one better. This is probably your favorite one, right? You know why you like this one?
Why?
Because, read that measurement.
0.43 inches.
0.43 inches, right? Now watch this. Read that measurement. Still says 0.43. You see that 0.400? And then 1, 2, 3. It still says 0.43, but it's a lot harder to read, right? This one makes it so easy. So people really like these, and you'll probably like it too, because they're so easy to read. You don't have to know about math. So like this thing, remember I said you had to add 1/16, and then you had to add up the 1/28 to figure out how much measurement you ended up with, and you end up with some horrible number, and you have to reduce the fractions, and then you have to come up with some thing that's hard to understand, right? That simplifies it. There's a problem though.
Why?
What do you think the problem with that is?
You gotta change the batteries?
The battery. The battery always fails. Every time I want to use this thing, I pick it up, and the battery's mostly dead. This one's got a good battery in it now. They're cheap though. This was like $6.
How do you change the battery?
I think you have to take it apart. I don't think there's a battery door. I think you have to take this apart. This cover here, I think, has to come off. It wasn't expensive though. It was cheap, but it's also probably not terribly accurate because it's so cheap, right? These are plastic, so they could wear, they can twist. So it's probably not terribly accurate. This also probably not terribly accurate. All this is fiberglass reinforced. It's probably still not terribly accurate. You can see a gap right there already where I've used it enough to kind of wear the jaws a little bit, right? But these are simple measurements, so we can use these to measure stuff. And then we need to get into fine measurement. And that's what those are for, right? Can you reach them? Stretch real hard. This is the one I use most often. You can bring the boxes too.
First treasure box of the day.
We'll set them over here. And set the other one up there and we'll look out. This is my favorite one. Not because it's a good one, but because it's a cheap one. So I tend to carry this around the shop and I drop it and I set it down a lot and it gets dirty and it gets filthy. So they make way better dial calipers. This is my favorite one because if I break it, who cares? I'll go get another one, right? If I broke an expensive one, I'd be upset. So this is still dividing the same inch though, right? So remember we said you could divide this inch into 1,000, right? 0, 1,000. And all the little tick marks in here, we're just dividing it up. So let's learn how to read it. You want to learn how to read it? There's 1,000 of those. All right, ready? Learn how to read it?
Yep.
All right, so there's 2 numbers you got to look at. See all these, well, actually several numbers. See those 1, 2, 3, 4, 5, 6, 7, 8, 9? Those are hundredths. And see where you get to that big one? That's 1 inch. Right there would be 1 inch. Well, actually be there. See, the dial can help us get more accurate. That'd be 1 inch, and it goes to 2 inch. And notice there's 10 spaces between every inch, right?
Now I might use that to measure it instead of the dial, because
Measure what?
the ruler, because it's a lot easier.
Well, let's learn how to read it, all right? So if I stop here, we got 2, right? And if I just stop randomly, let's tighten it up. So right there, they probably can't see this, but what we're looking at is we got a dial here. We can ignore the dial for now. We got this rod down here, right? And we're at the 1, 2. So we got the 2. We're at the 2 mark, but we're a little past it. We're actually right around here somewhere. So what the dial does is it sits up here, and this would be the 0 mark, right? And if we look at this dial, so now we know we're at 2. So that means we're at 0.2, and then we need to figure out what's after 0.2, okay? So I chose a random number. So we got 0.2, but where's this needle point? Can you follow the numbers around? 10, 20, 30.
32.
30, it's about 31 and a half, but right. So 30, we'll go with 32. If we did the 1.5, it'd be 31.5, which would be even more
So
decimals.
it'd be 2 30-seconds?
232 thousandths of an inch. This measures in thousandths. So let's try it again. Ready? I'm going to do it all by yourself now. I'm just going to stop it randomly. Now remember, we start with the first digit. So notice the first thing, what are we past?
We'll pass the big 1.
That means we're going to start here.
So 1 point...
And then we knew the other numbers.
73 about.
No, we're missing these numbers. What about this number right here? We got 1 there, and what do you got here?
1.4.
1.4, and now we look at the dial.
Is that...
And we're at 60. This line here would be 65. See that longer, slightly longer line? That's 65. So what do we got after that 65?
Well, 66.
About 66. We're at about a half again, too. We'll just go ahead and put the 6 on this. So we'd be 1.4, 66, 5. This would be the measurement we just measured on those calipers. So you want to try one?
Yeah.
All right, what do you want to measure? We measured this marker last time. Grab onto it. Come over here so I can see you. All right, grab onto those things and see if we can figure out how to measure it. Get in over here so they can see you. All right, now I like to tighten this screw here. That screw, if you snug that up, now your measurement won't, because it'll stop this from moving real easy. Oh, you got it too far back. You see these flats? See this thing here? You need to measure here, because see how it drops down there? You hold it there, tighten it down, that's your measurement. So let's start reading it. What are we going to get?
We got a little bit after the tiny 8.
So we have 0.8, because we don't have a 1, right? 0.8. And then we need to look at the dial.
About almost at 30.
Almost, but count from the 20. Where do we get?
$27. 27.
So that would be our measurement. That's how big that marker is. And I think last time we measured it, it was about 8.25 or 8.3 or something, right? We measured it with something else because we used this marker before to measure last time, I think, right? So you figure out how this works?
Yep.
You can measure with this, right? All right. So you know how to use this, right? Okay, we can get you one. And you can learn how to use it. So we got extras. So this one still isn't a great one, but it's better than that one, right? So this is like a really cheap, almost throwaway one. This one's a little bit more accurate, still not great. But I keep it in there because this one, if I need to be really accurate, I know I haven't thrown this around on the bench, right? I haven't wore it out, I haven't bent it, I haven't done it.
How come this foam is hard?
That's just because it holds it. It's just a padding. So when you put this in here and close it up, it keeps it from rattling around a lot. All right, get that one out. What's that one?
Another caliper.
But it's different. Look at this one. Let's look at the numbers on them.
This one has 1, 2, 3, 4, 5, 6, 7, 8, 9.
It goes around twice, right? So this goes to 0 on this side, and then it goes halfway around and gets to 0 again. So it doesn't go all the way around like this one does to get to 0. But notice also we have these, and those aren't inch marks. They're metric. Remember we talked about metric, they did it differently, right? So instead of dividing things up into a bunch of measurements like we did for 1000s, they just started with little tiny millimeters, right? So this measures in millimeters, but notice these decimal points. So it starts in millimeters, but notice this one is 0.1, 0.2, that's 1/10 of a millimeter.
1/10 of a millimeter?
So tiny, right? So if we measure this one, it works the same way. So we start with, let's just start here. All right, so where's the last big number we're at?
2, it looks like.
2, and then we're going to point to get up here, right?
It looks like, I think it's 8.
It's a little past 0.8, right? But we can go 0.8, and if we had to measure that, we'd probably say that's 5, right? Millimeters. And then if we go this, actually that's not right, it's 2.08. Sorry, hold on. There we go. 2.8 would be over here, right? So we got 2.08 millimeters. I forgot a 0, which is easy. That's how you mess up the measurements, right? So you know how to use both of these? When I want you to measure something, I'm going to be able to hand you this, and you're going to be able to measure it.
I think, yeah.
Yeah.
Zero your caliper.
I'm gonna check you again. All right, big box. We already looked at that one. That's the metric. Well, let's put the metric one back. I like the metric one because I don't use it very often, but it needs to be there when I need it, right? All right. So these are different too, right? Get the other one.
They're longer.
They're longer. So sometimes I need to measure stuff that won't fit into here, right? And these are longer. So these measure up to 12 inches.
Have you ever measured something, let's see, this long?
I don't know. They can't see in the camera though, right? That'd be, oh, what would be? That'd be pretty long because right there would be 12. So that's over 12 inches, right? This one's digital too, and I don't use it very much.
You learned how to, did you put a battery in it?
No, I fixed the battery. It's loose. The battery came loose. Let's see if we run it all the way down there, we get 12.108. And right at this measurement here should be, we could get right at the 12, right, on the scale. So this does bigger stuff. This will turn off on its own. So set that one in there. I like this one better. Again, why do you think I like this one better? We just talked about it. That one didn't work last time we played with it, right? Why didn't it work?
Because the battery is loose.
The battery didn't work, right? So I don't like that one because every time I pick it up, the battery's dead. And this one here, guess what? The battery never goes dead. Always works. Every time I pick it up, it works, right?
But the crystal's already dead.
I need to get a new crystal for it, right? Someday I'll do that. But I don't use it very often. I don't measure these things big very often. But let's see. See if we can measure it. So let's pick a number. Let's set it there. All right, you remember how to do it, right? So here's your starter scale down there.
Looks like it's big one.
1.5.
5. Looks like it's...
Always go from little number to big, even though it's upside down, right?
45.
45, right? So that's 1.545 inches, and those marks just mean inch, right? So now you know how to read a dial caliper. And it's not that hard, right? You start with the big numbers, 1, and then you go to 5, and then you look at this dial, and you follow it around until you get your measurement. So now you know how to do it, but put this back in there so we can, when I need to measure something 12 inches, I'll need those, right? are. Why is it fighting me so much? It's because I got 2 in one box. That's the problem, right? All right, close up. And then we'll have those when I need them, right? This one here, super easy. Digital. But you need to know how to read it. Oh, we got a 0. You need to know how to read it elsewhere too, right? 0. So we should have compared them. Let's do this. All right, ready? I'm going to get you a number. All right, let's write down this number. We'll compare the two. So what number does that say? What's our measurement?
Looks like
We didn't get to 1, right?
9.
Point, we're all the way to 9? We're not quite to 9. We're at 0.8, right? 8. And then what's that up there say?
71.
0.71. So that says it's 0.871. Let's check and see what this one says. Let's compare them, right? So theoretically, these should be the same, right? 0.88. I missed it. Hold on right there. 0.88. So pretty close. I'm still missing it. 0.8. Yeah, there's 0.87. That pretty close, right? They're pretty accurate. Here it's not though. Look, it says 0.86 there. Measure down here. That's a lot of plastic. Yeah, they're off a little bit. This one isn't very accurate, but it was like $6, so I bought it to measure quick measurements. And most of the stuff we do, we don't need to be that accurate, right?
How
So we
come
can
the
get
crystal
by.
on here feels plastic?
You can't see what you're talking about.
It feels like the crystal's
You gotta get over here.
plastic.
It is plastic.
Well, how can they call it a crystal if it's not real
It's just
quartz?
because when watches, they used to have like a crystal on them, and then that's just the name. They just called them crystals, even if they're this. This is probably plastic too. That might be glass. Probably high carbon type, carbon, whatever you call that stuff, right?
You can't ever lose the crystal on these, though, so nothing ever goes dead.
That's why I like these, right?
Except for when your muscles go...
First of all, look how small it gets. I can stick this in my pocket. Right?
I can stick this in my pocket, but I can't stick it in my sweatpants.
So if I wanted to measure something like outside in the field, or if I was out just quickly doing something, I can measure stuff, and pretty accurate, right? I mean, it doesn't get down to thousandths, but I can get close enough. So I like this because it fits in my pocket, and I can carry it around.
If you pull it out, you can use it like a ruler.
Well, it is a ruler, right? So it just measures between here and between outside of those pieces. That's all it does.
It's just a ruler pinned to a jaw.
Kind of. That's all they all are, right? That's all these are. That's just a ruler that has these jaws on it, so you can measure outside stuff and inside of stuff. That's all they do. And that's all the caliper does. That's all that one does too.
So I can easily measure.
Well, you can't see you. You gotta get over here.
Let's see. Looks like that'd probably be 1 inch.
Well, I don't think it's 1 inch, so you're looking at the metric. See that 10? That'd be 10 millimeter. But if we put this back together, like this, we can do this. And then, if you look, see that quarter right there? And then we go past it to that one right there, right? So remember we did this, if we have to divide this up, we can divide it into stuff, right? So we can go 1, 2, 3, 4 eighths. Half inch would be 4 eighths, right? Because that's half. So we can kind of cheat. 4 eighths would be ½ inch, right? Remember we did the whole reducing? That's the same. We're not to ½ inch yet, because ½ inch would be right here. We're less than that. So we're actually just a little bit over 3 eighths of an inch, right? And if we wanted to measure in 16ths, we could go right to that line. Let me get my pointer. See that line right there? Those are 16ths, so count those. How many do we have?
11.
13. You can cheat a little bit, right? So what is half of, we're doing 16, so what would be half of 16?
$50. No.
Half of 16. What makes 16?
8.
8. But notice, this is still the same. These are all the same measurement, right? What's changed is this and how they connect together. So we can cheat. We know we're not to ½ inch yet again, right? Just like we weren't to the 3 eighths. So we know it has to be less than 8/16, right? Or it has to go up to different. We can do it. So it has to be, that'd be 8/16 to be there. Let me see if I can count these. Are they 30/16 or 30 seconds? Let me see. I think they're 30 seconds. There's my problem. So we got 30 seconds, right? So that's the same thing here. What's half
Is
of?
that a pen or a punch?
It's a scribe. So the same thing, we could go up again, and that again would be the same thing, right? 30 seconds. So let's see how many we got, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That means we have 13 30 of an inch. We could do that every time, right? But wouldn't it be a lot easier and faster if we went to decimals and just used this, right? I shouldn't have closed it up. We could have compared and see what the decimal means. Let me find it. Let me get back to where we were. Right there's where we were, right? So let's see what it says it is. So inside here, it would be 0.4 inches if I use the right number. I'm not sure if I use the right number. Same number. I don't have very good memory for that kind of crap, right? So you understand how it works? And they all turn. Did you notice all the dials turn?
Yeah, all of them do turn.
You know why?
So you can zero all of them.
That's right, because you can zero it, but it goes better than that. See this? We can set this right at 0. And now it'll go to 0 up, right? But we can use this to cheat sometimes too. Let's say I already know that I have this measurement here, right? But I want to go bigger than that. And I know, put that on 0, and I know that I want to go 35 thousandths bigger, right?
I'm going to zero this.
There you go.
It measured down instead of, it went all the way around to 0, except for it probably out of 0.
Did you see how I just did this though? This is easy math. So what I did is I just added 35 thousandths to this by not doing math. Now if I did this other way, all right, so we got right there, we got 6, that's exactly 7, isn't it? Oh wait, let me zero it first, duh. 0. All right, so what's our measurement? Let me get it tight here.
Looks like 7.
We're not to 7. We're at 6.6, 8,
87.
88. Well, yeah, we'll go 88. Now, if I want to add 35 thousandths to that, what do I have to do?
35,000.
I need to go this way, right? Now, if I need to do all this math, right? But look what happens. If I just set this to 0 instead, loosen this up. If I just set this to 0 instead, and then take that away, and then add my 35 thousandths, now that's how big I need to be, and I didn't have to do any math. I just know I need to be this size, right? So I can compare stuff. So you can kind of use these to do a little math. You gotta make sure you put it back on 0 when you're done though. Otherwise, you'll mess up all the measurements for future stuff. So you're doing on, that one does it too. You were doing on that one? Let's see that one.
I was zeroing it all the way down
Put it over here so I
here
can see.
and then
They can't.
zooming it right back up.
They can't see you doing it. So you can do the same thing here, right? When you zero it out, it's harder to move this one. Zero it out, it's on 0, but let's say I wanted to measure something a ½ inch, right? And this does fractions. So I want to zero that out because that's my base measurement. That's a ½ inch. Now I want to add a 1/16 of an inch to that. So instead of doing the math, I could just go right there is how big that needs to be because all I did was add a 1/16 to it, right? We could have done that without moving it too, but sometimes it's easier to not have to think of big numbers, so you can kind of cheat. We'll have to talk about, next time we build something, I think you should have to do the measuring for it. What do you think? You think you can do it?
I think
You're getting really good at this one. We use this one the most. I do anyway, so we'll practice with this one the most. I use this one the most. That's why it's so dirty and beat up a little bit, right? I use this one all the time. They're not mechanical. They're not motorized.
It'd be kind of nice if they did, because then you could go,
How big would it have to be, though? And then...
It just have a motor bottom right here.
And then, right back to the batteries that never work if you did that. This, you never run out of batteries. It always works, right?
You do run out of batteries because they're in your cell, but those are still deep cells.
If I'm that tired and out of batteries, I just quit working. Go do something else. Go take a nap, read a book, right? All right, any other questions on this? All make sense to you?
Yep,
You know how to measure?
it
I'm
all
gonna make
makes
you.
sense.
I'm gonna make you measure next time. Yo job, measuring stuff.
I have a bad memory.
Yeah, so do I.